Hello, welcome once again to Omega Virtual Learning. This is lesson 1 on vectors, and a special welcome to our new viewers. What is a vector, one may ask? Vector is a quantity that has both size and direction. And a vector describes movement from one point to another. To best understand vectors, let's have a little review on translation of shapes. When translating shapes, we describe movement by considering first the horizontal movement, then vertical movement. The horizontal movement is at the top, represented as the X movement, and the vertical movement is the Y movement. And it's represented in the format X and Y in a bracket. It's not coordinate, it's called vector. And in both cases, could have positive or negative. Movement to the right is positive for X, and movement to the left is negative. Then vertical movement, upward movement is positive and downward is negative. So let's look at a simple example. If you want to consider translation of A to B or movement of shape A to B, the best thing is to pick two corresponding points. Then we see how far it moved. First, let's check the horizontal movement. You realize that this point has moved 4 units to the right. So that's the horizontal movement. Then 2 units up. That is the vertical movement. So using vectors, we can say the movement can be described by a column vector 4, 2, 4, 2. So since we're talking about A to B, a line from this point on A to this point on B is what we called the vector 4, 2. And we said a vector has magnitude and direction. The direction is from A to B this way. And if you want to know the magnitude, we use Pythagoras to work out the magnitude, which if we're doing A level, they would talk more on the magnitude. So this is what we call a vector. Considering movement X to Y, you realize that we move 5 units to the left and 2 units up. So the description of X to Y could be said that it's by a vector -5, 2. So the direction will be from X to Y will be this way. So this is what we call what? Column vector. Now that we've understood what a vector is, let's learn how to draw vectors. We've been given these vectors and we're supposed to draw the vector. That means 2 units to the right and 3 units up. Then which means you make a straight line from this point up to where it ends. And that vector is 2, 3. B is -2 and 4. Remember, the top one talks about the horizontal movement and the bottom one the vertical movement. So -2, 2 units to the left and 4 units up. So the direction will be from this point upwards. So that's the vector. -2, -3, 2 units to the left and 3 units down. So the vector will go downwards from this point to this point. The last one, 3, -1. Okay. Now what about if the vector is already drawn and we're supposed to represent it using column vector? So we check. The direction is very important. So it has moved 1, 2, 3, 4 to the right and 2 up. So the vector is 4, 2. 1, 2, 3, 4 to the right, then 1, 2, 3, 3 down. So it's 4, -3. The direction is very important. So we start 1, 2, 3 to the left, 1, 2, 3, 4, 5 downwards. So it's -3, -5. 1, 2, 3 to the right and no upwards or downwards movement. So that will be 3, 0. Okay. Now having understood column vector, how to draw it, and how to represent it using column vector. Now let's learn how do we sum vectors, column vectors. So imagine that we've been given the vectors A and B. A is 1, -2, and B is 2, -3. Given these two vectors, we are supposed to sum or find the vector for 2a, a plus b, 3a minus 4b, and -b. Before we can really understand the sums of vectors, let's try to use diagrams to explain the 2a. Now, first let's draw the vector for a, 1, -2. So 1 units right and 2 units down. So the red line represents vector A. If you want to say 2a, or draw the vector 2a, it means the length of this vector should be doubled, because 2a, that means twice of a. So we double, and that is 2a. And if we check the column vector for this, you realize that it's 1, 2 to the right, and 1, 2, 3, 4 downwards. So it means that it's simply multiplying each of the components by 2. So the component is 1 and -2. If you multiply each by 2, we get 2, -4. So which means that 2a is equal to 2, -4. So that means that we just need to understand that 2 becomes what you call a scalar, or a constant if you want to call it that way. The technical term is a scalar. So knowing what happens, we can quickly sum vectors without necessarily have to use diagrams. So if you want a plus b, it's a matter of summing the components. 1 plus 2 and -2 plus -3. And that gives us 3, -5. What about 3a minus 4b? We must first work out what is 3a. 3 is the scalar, so we multiply each component of a by 3. So 3 times 1 and 3 times -2 to get the answer for this section. Then we multiply 4 times 2 and 4 times -3 for this section. Then we take away the two sums. So 3, 1 times 1 is 3. 3 times -2 is -6. The minus, we put it there, here. 4 times 2, 8. 4 times -3 is -12. And don't forget, here 3 minus 8, but it's -6 minus -12, and 2 negatives here make it -6 plus 12. And that will give you the answer, -5 and 6. Now -b means -1 times the component of b, -1. So -1 is the scalar, and that will give us that, -2 and 3. Now let's learn how do we add two vectors. Given vector a and b, we can show the addition of two vectors using triangular law with the animation below. So that's what I'm going to do. We could have the parallelogram rule or the triangular law. I'm going to use the triangular law to explain to you. This is vector a and this is vector b. How do we show addition of a to b? Now what happens is that when you are showing addition of vectors, the second vector, in this case b, must start from where vector a ends. So this is vector a. If you want to add b, b should start from the end of a. And a line from the beginning of a to the end of b is what we call the addition of the two vectors. So a plus b is what is represented by the red and the green line. So the black line is the vector. What about, and what you need to understand is that this is also called the resultant vector. A plus b is called a resultant vector. How do we show subtraction? Okay. You need to understand the direction is very important in vectors. Movement this way is vector b, so movement directly opposite is what? -b. So if you want to show a minus b, that is vector a. This way is vector b. So if you want to say minus b, it has to be the opposite direction. And we have to join from the beginning of a to the end of -b. That shows a minus b. So having understood how to add and subtract vectors, we are supposed to use vectors y and x to rewrite these vectors. Note that there are three ways we could write vectors. So, for example, this line is vector BC. It could be written with a B underscore with a line, or BC with an arrow on top, or B in bold. They all represent notation of writing vectors. So this is what you need to understand. So we are supposed to use A, B, C, and D, write vectors for A, B, C, and D only in terms of x and y. So we check. If you check vector A, you realize that it's moved this way and that way. So the only movement given to S is y and x. We can check. This is movement on for y, and that is a movement for x. So that is 3y movement, and that is 2x. So that is the summation of 3y plus 2x. So the answer could be 3y plus 2x, or 2x plus 3y. It doesn't necessarily matter the order now. Let's check B. B is simply 2x. As you can see, 2x. There is no y component. What about C? We move opposite direction for y is 2 units, so it's negative 2y. And then down also for x, 2 units. So that will be negative 2y minus 2x, or negative 2x minus 2y. The last one is 3y, then downwards, so that's minus 2x. So that sum of that vector will be 3y minus 2x, or negative 2x plus 3y. So that brings us to the introduction of vectors, the end of lesson 1. And from lesson 2, we're going to do proper vector algebra, and we'll be talking about vectors with ratios. That's lesson 2, vectors with ratio. Thanks for watching, and share with your friends.